My name's John Stevens. I'm a master's student at Western Kentucky University, and I'm going to talk to you today about economic growth, economic development in the Southeastern United States. First, I'm going to show you what determines economic growth through variables. I'm going to give you a brief history of economic development. I'm going to talk to you about my specific research. I'm going to state my equation and how I came to that and the research behind it. I'm going to show you some specification problems I had with my initial equation and how I fixed them, my irrelevant variables and my omitted variables. My regression actually had multicolinearity, serial correlation, heteroscedasticity, and I'm going to explain how I solved for all those. My paper talks about what drives growth in mid-sized counties in the southeastern region of the United States. Why is this important? Well, most papers talk about economic development with nations. For example, Barrows has done numerous research papers. What determines economic growth? In one of his papers, he found that education, democracy, rule of law, and economic freedoms all drive economic growth. You can see three flags on your screen right now. You have the European Union, the African Union, and South Korean flags. Now, the European Union has remained as a high GDP per capita for the last 100 years, and the African Union has remained at a very low GDP per capita for the last 100 years. Now, how does a country like South Korea, who in 1952 was the exact same GDP per capita as many of the African Union nations, go to 2002, where they're almost the same as the European Union? And why does Africa remain the same after 50 years and not grow with GDP per capita, does not have GDP per capita growth? Pair studies have been done on nations, including Germany and Korea, talking about capitalism versus communism. They show that communism is not as effective as capitalism when talking about growing GDP per capita. Studies have also been done on state pairs. Western Kentucky University's Professor Goff, Lebedinsky, and Lyle found that taxes matter when it comes to economic growth, as does being a right-to-work state. However, some things surprisingly don't affect economic growth, as corporate taxes and regulatory measures do not affect economic growth in states on the state level. This study talks about the southeastern United States. You can see several different states here, and I picked 11 different counties in this region, from Alabama, Georgia, Kentucky, Louisiana, Mississippi, and Tennessee. All these cities had a major university in them. They all had a major highway, a major railway. They had about the same balance of industry, around the same number of residents in the area, and none of them were poor. The research took place over a 20-year period, as I picked the percent of people in the private sector, the percent of people with a degree of educational attainment. I picked both high school and bachelor's degree, the unemployment rate, the amount of people in the manufacturing sector, the amount of people in the construction sector, the median housing price, the concentration of small businesses in the area, and the last variable I used was the Economic Freedom Index, which talks about government intervention and on different policies, public policies. My initial equation was the log of GDP per capita to show that it was a percent change, was a function of the unemployment rate, the amount of people, the percentage of people in private employment, the concentration of small businesses. We'd see that as the concentration of small businesses grow, this would actually negatively affect GDP per capita, as small businesses usually mean that you're going to have a bigger retail sector, which are the lowest wage jobs. Um, Again, we have housing. The number of establishments in a community at a increasing at a decreasing rate, hence the squared term in the second variable there. The construction sector, the manufacturing sector, the high school attainment, and bachelor's degree attainment. So my research problems. First of all, GDP per capita was logged, which I wanted to show a percent change, but this ended up being a real big problem when running the regression. I also didn't have all the correct variables, as in my first linear regression, you saw that I didn't have the freedom index, and I didn't have dummies for my states. So I'll show you those in a second. I tested for correlation, and I saw that the concentration of small businesses and the percent of people in private employment were really highly correlated. So we didn't know, as one increased, the other one also increased, so we had to eliminate one of those. I also checked for multicolinearity using my VIP statistic, and I had that omitted variable of the freedom index added in. When I ran my regression, wow, I had huge multicolinearity with VIF scores well over 5,000 for a few of them. A VIF score over 5 is pretty bad, so this was really, really bad. So after trying several different things and eliminating variables, I finally determined that logging GDP per capita was my problem. Since there's such a low variance in my dependent variable, it raised my VIF scores. So that was my first specification error. My irrelevant variable, I had bachelor's degree in there and high school degree. Now, they were defined by high school degree or more and bachelor's degree or more, so that means they were picking up on each other. So I got rid of bachelor's degree, and again, my omitted variable of. So after running my new regression, my VIF scores are really far down compared to my old VIF scores, and you can see that a few of my variables are not statistically significant, including housing, construction, manufacturing. Construction and manufacturing makes sense, as research shows that diversification of your industries is going to determine higher GDP per capita in the long run, because if the economy takes a hit, the other sectors will make up for it. Housing was investment, so I guess GDP per capita doesn't matter for that either, as that's more of a consumption function. Being in Georgia or being in Tennessee also didn't matter. So I voted these guys off the island. Bye-bye, guys. And that left me to my second round. As I had GDP per capita, my freedom index, private employment, high school attainment, unemployment, being from Mississippi, Alabama, or Louisiana. And as I ran this regression, you can see that I have good p-scores. My adjusted R-squared is 0.55, meaning the model explains about 55% of the variation in my dependent variable. Mississippi was not statistically significant at this point, but I will change that later. Then I looked at the graph to check as my dependent variable showed signs of serial correlation. Also, I checked it using the Durbin-Watson test. It showed positive serial correlation, so I corrected this with the Nui West. My parameters remained the same. Those are the coefficients on my betas, but my standard errors increased for my betas. So freedom, the freedom index, the unemployment rate, and being from Mississippi proved not to be statistically significant at this point. I also checked for heteroscedasticity. I used the White's test and found heteroscedasticity with a chi-squared score of 57.52. My rejection region was 12.6. And also, so after that, I did the White's correction. This increased my standard errors, but all my variables proved to still be statistically significant even after the standard errors were increased. So this left me to my final equation. As you can see, as private employment increases by 1%, this is going to raise GDP per capita by $28,000. As 1% of the population gets a high school degree or more, that's going to increase GDP per capita by $60,000. And being from Alabama and Louisiana, it's going to increase your GDP per capita also. So you can see my final findings. In the model, it was statistically significant for education, private employment, and those dummies, but it really didn't matter about unemployment or the freedom index, which contradicts theory. Some of the problems I had with the model that I'd like to get back to. Obviously, those coefficients were so robust. There must be some omitted variable bias. So that should be taken care of in the next regression with more research and adding in different variables. Also, one of the problems I had with this project, it was panel data, but I had to use a regular linear regression since I didn't have the training behind a panel regression, and I would have liked to change that. So there's all my research, and yeah, thank you.